Hey guys, this is Logic Crazy and I'm Jonathan, and welcome to yet another Chess Engine tutorial. We're going to be focusing in on some modifications I have made so that our engine will be able to find all of the black piece moves as well in addition to all of the white piece moves which we've already been able to generate. So before we get into that though, I should mention that I have also created this method called unsafe for white, and is basically the same as the unsafe for black method, except the only two things you need to change is one, all the bitboards that used to be white pawn or white knight got changed to the black knight and the black pawn. So that was one change, and the other change were these two little shift operators. They used to go to the right like so, and I had to change them to the left because pawns are now moving in the opposite direction than they used to move. So those were the only two changes made between those. And then I decided I needed to create this other method called possible moves black. But to do that, there were a couple options I had. One, I could duplicate all of these, for instance, possible white knight. I could have made a possible black knight version of it. But instead of that, I just made these methods more generic so that they could work for either white or black. And that way, if I want to change the code, I wouldn't have to go to two different methods and make the same changes. It just reduces the amount of debugging issues and also just the number of lines of code that needed to be done. So to do that, the first thing I did was I renamed these. Instead of possible white knight, it's now just possible knight. And an easy way of doing this is to right-click on it and choose refactor. This should work in most IDEs. There should be some method somewhere called refactor. In NetBeans, you can just press Control-R on the keyboard, and you can rename it. And all the instances of that variable will be renamed. And if it's a local variable, only that local variable will change. Other local variables with the identical name will not be adjusted. So it's a smart name changer there, and it saves a lot of time. The other thing I did was this variable that we bring into this method, instead of being a white knight, I just made it more generic again by calling it a knight. And the rest of the code basically stayed the same except for a couple other name changes, and these changes don't really affect the way the program operates, but more makes it logical to what's really happening. I changed this method from not white pieces to not my pieces. So now instead of dealing with white pieces and black pieces, we're dealing with my pieces and your pieces. So it's more generic. And I did basically all the same changes to the possible bishops and rook and queen and king methods. However, I had to do something special for the white pawn movements because pawns are all directional and there's en passants and there's all sorts of fancy stuff going on. It is a little more difficult to make it generic. So what I did was I basically copied and pasted and made several modifications. Obviously, one of the things I did was I always changed the shift direction. So instead of pawns going one way on the board, they now are going the other way. Another thing I did is instead of having rank 8, which always eliminated things like pawn promotion, now pawn promotions happen at rank 1. So I had to change that. And thirdly, because capturing to the right now is capturing in the opposite direction, all the files had to be swapped. A's and H's had to be swapped around. So those were just a few of the changes here for the basic moves. Some of the more complicated stuff had to be changed in the en passants and such. I had the file mask 8 would stay the same, but we had to change from rank 5, I believe, to rank 4. And always changing the shift operators. And also, every time we add the move as a list, you have to change often from plus to a minus. If ever there's a plus one, it'll tend to be the -1. You just have to logically work it through so that the list move makes sense to the move being that it came up with. So those were the basic changes I did. It took a little bit of work. Obviously, I also swapped the inputs so that you take in black pawn as the main one and white pawn as a secondary one, which is opposite of our previous possible white pawn method. And then I put all of these together. I combined them into our possible moves for black method. So it takes in all the same items in the same order, and it again figures out not my pieces, but instead of being not black, it changes them all to, or not white pawn and white knight, it changes it to black. So I just invert all these. My pieces, again, they used to be white pawn, white knight, and so on. So I just swapped all that. Occupied stays the same, as does empty. And then when I come up with my list, the only thing I change is to black pawn instead of white pawn, and set these in the appropriate order. And then I send them all their pieces. So instead of having, as you can see up here, in our previous method, I would send them white queen, for instance. Now I send it black queen. So always just the opposite of the way it used to be. And now if you were to run the code, I believe I have just a starting position here, and I know that the possible moves white will already be called, and we will add a little method here. I'll just say int temp equals list dot length divided by 4, and then this will tell me how many moves that it came up with. And we will also then call possible moves black. Should put all that in there, and that should get me all the other ones. So I'll put a little debug stopper there, and also add this whole temp thing just before the return value there. And now we will be able to see at least how many moves each method gave. Doesn't necessarily mean that it didn't make any errors, but it at least indicates that each side could make 20 moves at the start. So the first thing we see is that there are 20 moves. When we continue the code to the other stopper, we see again that there are 20 moves. So you can go through each item in the list and make absolutely sure that that I did all this right, but I believe it should all work. So just download this code. It's a lot more bug-free if you do that than if you try to write it all in. And if you do write it in, though, great for you, but just make sure you debug it, and otherwise you will have more errors down the road. Until next time, enjoy Java.